Oh, hello, friends. Blockchain and Bitcoin. Actually, blockchain is a distributed ledger-based technology. Normally, in any financial transaction, the ledger is maintained by a bank or a entity which is centralized, and it maintains a record of money coming in, money going out, and to whom the money has been sent. So in distributed ledger, this particular ledger is distributed across many nodes. Basically, everybody maintains the ledger, and the whatever transaction happens in one particular ledger gets reflected into the other ledger also. They have a protocol wherein it gets updated. So, blockchain is based on distributed ledger concepts, and also in centralized ledger scenario, there is an authority, and they are supposed to ensure that it is not tampered or it is safe and it is correct. So, in distributed ledger, there is no owner of this particular ledger. So anybody can participate in that activity. So because of this, there are inventions that are related to cryptography that has been used in creating and maintaining this distributed ledger, and this has been used in Bitcoin blockchain. Okay, in Bitcoin blockchain, there are two three concepts. One is there is a user, and the user is identified by a public key, and a address is derived from the public key. And what you see is a public key and a private key pair using elliptical curve algorithm, which is a mathematical formula wherein you create a pair called public key and private key. And private key is something that the user has to keep it private to him. He should not share it with the public, with anybody else. And whatever the data is there in the blockchain, if that has to be moved, that is the transact that assuming there is a bitcoin that has to be spent, the particular user has to sign with this particular private key, requesting, basically when he signs transfer one bitcoin to another address, that particular person has to sign with this private key. And there is a person called miner who is nothing but a ledger keeper. He will verify that this particular person having this particular public key is the correct person because he has signed with his private key. This miner will verify the signature. Once he had verified the signature, he will move that money in the in the address of this particular person having this public key to the another person. Assume this signature is wrong, then the miner will reject it. Okay, so the money cannot be moved. So in the blockchain network, we have this public key private key mechanism to identify the user, and this has been very neatly explained in the Bitcoin white paper. And there is a concept called hashing. This hashing is a way of getting a unique string for every data. So in the Bitcoin blockchain, actually there are various scripts which are nothing but small programs which run on opcodes like processor opcodes, and these are some of the standard scripts called pay to script hash and pay to public key hash. Okay, these are two formulas which are executed for creating a condition to verify if the person who is trying to transfer the money is authentic user. And whatever transactions happen that is moving the bitcoin is recorded as transactions, and many transactions are grouped together to create blocks. So we will see this next in the next slides. Okay, here I mentioned about blocks. So each transaction uh, there is a block, and these blocks are chained to one another such that these blocks cannot be changed once a new block is created or many new blocks are created after a particular block. So this method of chaining is done by this technology here called uh, by the proof of work technology. So here what they do is they try for any data that is been uh, that has to be processed. A unique number has to be found. What you see here, 0, 1, 2, 3, etc. And here we see last number, I think 4, 2, 5, 1. I think it is masking, but you can see that. Um, yeah, you can see here 4250 at the bottom, and there is one more below. Okay, so what they are doing is they are trying to find out this last four digit has to be zero. Okay, there is a last four digits. What you see here has to be zero. Just a minute. Okay, that in this particular row you can see. Okay, yeah, here you can see. The user has to repeatedly search for a number such that the when the hash of that is done, the last four digit has to be zero, and here the hash is SHA-256. So once that is found, it means that the uh, proof of work has been done, and now next time somebody has to verify if this data is tampered or not, he will just do a hash and check if the first four digits are zero. So that way verification is very easy, but at the same time creation is very difficult. So if you assume there are some 10 zeros has to be created, then it takes a lot of computing power. So the proof of work computation takes a lot of uh, computing power. So that is the reason people tell Bitcoin is a highly power consuming ecosystem. Okay, so if four or five blocks are chained and each of them have a nonce, there is no possibility of anybody tampering these records unless they overwrite all the blocks. So this is how they are able to achieve the non-tamperability of blockchain data. And the people who find this particular nonce are called miners, and these miners are paid rewards and fees. Reward is paid by the Bitcoin ecosystem. This was useful in the beginning, where there were very less transactions happening, and gradually the rewards have been reduced, and now the miner collects the fees from every transaction. And normally the fees is part of the transaction, where if the assume if a transaction is moving one bitcoin, uh, say some few satoshis, that is 0.0001 satoshis may be left out when they move, such that that particular difference is used as fees.